Welcome everyone. So in this video we're going to see how we can find the derivative of the functions of the form f of x equals e to the power x or y equals e to the power x, where y is a function of x. Okay, let's look at a specific example to know more about it. So the function I'm going to choose in here is x square e to the power minus x square. So this has an exponential function, a function of this kind in here. So it's e to the power minus x square. Okay, so we need to know what is the derivative of this function. If the function is of this kind, an exponential function with base e, then the derivative of this function f dash x is e to the power x itself. So the function itself, we are not going to see how we got this result. We can prove that by using the first principles, but we're going to use this end result and going to apply a knowledge of the derivative of exponential functions of this kind in here. Okay, but looking at this specific example that we're going to find the derivative, so the function we're going to find the derivative is x square e to the power minus x square. So that's not exactly of this kind. Instead, that's the product of two different functions, x square and e to the power minus x square. So we need to apply some of our previous knowledge on derivatives in here. So when a function is the product of two functions of x, we need to use the product rule to find the derivative. So the product rule is, if function is the product of two functions, if y equals uv, where y is a function of x, which is f of x in here, and then the derivative is y dash or f dash equals u v dash plus v u dash. Okay, so this is what we're going to use in here. This is the product rule. Okay, so first in here, so u equals x square. Well, it doesn't matter which one you choose, but if you choose one as u, the other one is v. So the v is e to the power minus x square. Okay, now we need to find the derivative of u dash and v dash. So the derivative of u dash is, the derivative of u dash can be obtained by applying the power rule. So because this is of the form, because this is of a, so to find the derivative of u, we need to use the power rule, because this function is a power function. Okay, so the power rule says if the function is x to the power n, the derivative is n x to the power n minus 1. So in this case, n is 2 x to the power n minus 1 is 1. So it's a 2x. That's the derivative of u. And what is the derivative of v? So what is derivative of v? So that's where we're going to use our knowledge on this particular function e to the power x. Okay, but that's not the only thing we need here, because the function is not exactly of the form e to the power x, but instead it's e to the power minus x square. So this itself is a function of x. So this is a composite function or a function of a function. So to derive such kind of functions, you need to use the chain rule as well. And the chain rule always works like you take the derivative of the outside function and then you take the derivative of the inside function. So if I'm using that logic in here, the chain rule in here, the first function, so this function is e to the power minus x square. So we're taking the exponential of this function minus x square. So this is the outside function, the e to the power. So we need to first take the derivative of that one. So that's e to the power x itself. So in this case, the x is the inside function. So when you taking the derivative of outside function, don't do anything to the inside function. Treat it as a single variable. Okay, so that's a minus x square. And once you've done that, you take the derivative of the inside function, which is minus x square. So that's the power rule again. And there's a constant as well, so we don't do anything to the constant. The constant is minus 1 and the derivative of x square is 2x. So this is nothing but minus 2x e to the power minus x square. So that's the derivative of v. So now it's all about substituting u, v dash, v, u dash into this equation to find the final expression for the derivative f prime x. Okay, so f prime x or f dash x, doesn't matter which way you call it. So f prime x, or that's same as y prime as well. So that equals u is x square and times v dash is this one, so it's a minus 2x e to the power minus x square, plus, going to write on the next line, so it's a v is e to the power minus x square times u dash, which is 2x. Okay, just need to tidy up a little bit because it's a negative term. I'm going to write it as the second term. It doesn't matter whether you write it that way or not. Just make it as neat as we can. So that's equals 2x e to the power minus x square minus 2 times x square times x is minus 2x cube e to the power minus x square. So that's the final result. So there's other alternative forms as well. So for example, if you can put 2x e to the power minus x squared to the outside and then put everything else in bracket, that's another form. That's not required, so you can leave the answer in here. Okay, so basically in one question you need to use multiple rules to get the final answer. So in this case, we used our knowledge on exponential functions, we used our knowledge on product rule, chain rule, all in one question. So it's really important that you understand all these concepts really well to do a problem in differentiation properly. So if you don't know how to approach this product rule and chain rule, go back and watch the videos on product rule and chain rule. Okay, let's stop it here.